Subtracting fractions. The rules for subtracting fractions, the idea for subtracting fractions is the same as it is for adding. So I reposted the rules there if you want to write them down again. And we'll use our chocolate bar analogy again. So I'll start by drawing a chocolate bar to see if we can make sure that we understand what's happening here. All right. So we have the idea of 5/6. So I could take one chocolate bar and split it into 6 sections. And my other chocolate bar and split it into 3. And again, I'm going to do my lines, some horizontal and some vertical, because I think it's going to possibly help us see what's happening. Now this question is saying, this question is saying that you have 5 pieces of a chocolate bar, and then minus 1/3, for subtracting, this is probably even more realistic than before, is you eat 1/3 of a chocolate bar. Is your chocolate bar all gone? How much do you have left? Okay. So one of the things that we need to do is we need to get a common denominator. So what we're looking for, is there something in common between 3 and 6? And what could that be? They're a multiple of each other, so we could make them both over 6. Okay? The question is, 1/3 is how much over 6? Like this one is really easy. If we keep them both over 6, we'd have 5 over 6. How do we change 1/3 to be equal to something over 6? Well, we would have to cut each of our thirds in half. And then this piece is the same as this piece. And so if I can multiply this by 2 to get 6, I can multiply this by 2. And now the idea is we had 5 pieces, we ate 2 pieces, we have 3 pieces left. And we get a fraction that's 3 over 6. Now our final answer, in this case, we always want to write our fraction in lowest terms. So when we have something like 3 over 6, we can reduce this to 1/2. 3 out of 6 pieces does probably visually make sense that that's half the chocolate bar. And also, you could say, is there a number that I can divide both 3 and 6 by? I can divide 3 by 3, I can divide 6 by 3, and so that's how I get 1/2. Now another thing that I want to show you with this one, these were easy numbers to make 6. But there's sometimes, I'm going to erase this right now. There's sometimes what you might want to do is take these lines here and take our green lines here and put them together. And you make a chocolate bar with a lot of pieces. How many pieces does that chocolate bar have right now? 18. Okay? 18 and 18. This isn't wrong to do it this way. It's not the lowest common denominator. We already did the work by, and sometimes mathematically you can see that lowest common denominator right away. But if we had 5 out of the 6 pieces in blue, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of the 18 pieces once they're put together. Does that make sense? Can you see that? If I took 5/6, which is this row, this row, this row, this row, and this row, if you took all 5 of those rows, you'd have 18, out of the 18 pieces, you'd have 15 of them. Okay? And then we want to subtract 1/3. Well, 1/3 would be like a row this way. If I took 1/3 of my chocolate bar, a roll this way, how many pieces would that be? 1, 2, 3, 4, 5, 6 of them. So if my chocolate bar was put together that way in 18 pieces, 5/6 would be 15 out of those 18 pieces. And then I subtract, or I eat 6 of those pieces. What am I left with? 15 minus 6, 9 out of 18. Can you see if I shade in 9 out of the 18 of these pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you see that that is still equal to half your chocolate bar? And when we write our answer in lowest terms, we get the same answer whether we use one technique or another. So you're saying, Mr. JR, I wouldn't have seen that they'd both be 6s, but I like the chocolate bar and splitting it up into a bunch of pieces. I can do the pieces with 18. Perfect. You will get the same answer in the end. So here's some more to try. 7/6 minus 2/3. And again, I'll model it with the chocolate bars to start off with. Okay. What kind of fraction is 7/6? It's an improper fraction. Okay? It is equal to 1 1/6. So you actually had more than a full chocolate bar here to start with. The number on the bottom tells us the size of the pieces. So the 6 still means we're going to divide this into 6 pieces. But I would have, oops, that's not blue. I want brown for chocolate. There we go. I would have an extra piece. That's 7/6 of a chocolate bar. Minus 2/3. Okay? Option number 1. Maybe you're getting really good at this math. Maybe you can see a lowest common denominator right away and say, I can make them both over 6. If you can do that, excellent. And then off to the side here, I'm going to say 2/3 is equal to what over 6? Well, I'd have to multiply that by 2, so I multiply that by 2. I get 4/6. Now my pieces are all the same size. I had 7 pieces. I ate 4 of them. I'm left with 3. Yes? Class is almost over, so you can go at the end. 3 out of 6. And as a result, we can reduce that fraction. If you have 3 out of 6 pieces left, maybe you can see right away that's the same as a half a chocolate bar. Or you could divide both of them by 3 to get that answer. That's option number 1. Option number 2. Was that too fast to erase? No. Everybody good? Okay. Option number 2, we have our chocolate bar. We have our pieces that are 6s this way. We have our pieces that are 3s this way. How many pieces in a full chocolate bar? 18 again. It's kind of nice we have the same numbers. Now, if you had 7/6, that means you have a full chocolate bar, you have all 18 pieces, and if you had one more row, can you see that that other row would have 3 pieces in it? So if you had a whole chocolate bar, all 18, plus another row, you would have 21 pieces. Okay, again, 6 times 3 is 18, 7 times 3 is 21. Minus 2/3. Well, 2/3 would be 2 rows lengthwise. How many pieces in each of those rows? 6 and 6. You're going to get 12 out of the 18. Again, mathematically, 3 times 6 is 18. 2 times 6 is 12. 21 minus 12. Think of your number line. Start at 21. Subtract. Go back. You're going to get to 9. And you're left with 9 out of 18, which is 1/2.